الثاني هو بعنوان التطورات الحاصلة على أنظمة التأريض والحماية من الصواعق في المواصفات القياسية الدولية، وكيف يمكن لها أن تؤثر على المواصفات القياسية السعودية. يقدمها المهندس محمد عديلي، مدير تطوير الأعمال بشركة مينا العربية للتدريب والمقاولات. حصل المهندس محمد على درجة الماجستير في إدارة الأعمال من جامعة ليستر البريطانية، ودرجة البكالوريوس في الهندسة الكهربائية والإلكترونية من جامعة برادفورد البريطانية. لديه أكثر من 19 عاماً خبرة عملية في مجالات هندسية وإدارية في مجال الطاقة. مهندس محمد، لديك 20 دقيقة، وليس لديك الواسطة التي لدى الدكتور عبد الله لأنه درسني، فلو سمحت أن تلتزم بالوقت. شكرا لك.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Initially, I would like to tell you that I'm a little bit feeling unfortunate to be the first English speaking in this event, although I am not an English native. And I would like to thank Dr. Abdullah. He gave a very good introduction to go into the subject of specifically standards, international standards, and the effect, the impact of international standards on the Saudi standards, especially with regard to earthing, lightning protection, and the safety, because we are here all concerned about the safety and the impact of these standards on the safety of our mainly electrical, not only installations, but talking about power plants, substations, distribution substations, the whole network of our electricity, our power generation network. To start with, there was a little bit defragmented picture a few years ago, let's say 8 to 10 years ago, about the standards. We have international level organization developing the standards, like the IEC, concerned mainly with electrical, and we had the ISO, concerned mainly with mechanical, the environment, and also the quality. Okay? From there, we had the European organizations like Senelec, also for mechanical SEN, and we have the national level of organizations where SASO comes, where, for example, a British standard, BS, DEN, VDE, UT, for France, all these were active in a, let's say, disfragmented way a few years ago, let's say 10 years ago, okay? Just like what is shown here. But after some time in 2006, Senelec adopted IEC. So Senelec standard, what used to be, or what's still called European norm, EN, has adopted the IEC standard, okay? Now, part of the European regulation, all the European countries they were obliged also to adopt the IEC standard. So, all the national standards before used, like the BS, ELOT, DEN, NF, whatever, in this list or outside this list, by law had to be abolished, and the new IEC standard to be adopted. Where the SASO fits in all this? SASO has got a member. Okay, SASO has got a member contributing to the working group of the IEC. So SASO also made the step in 2011 to adopt the IEC standard. This is just a snapshot of the SASO standard from the website. And this is basically what other countries have done. Everybody is just talking about adopting or replacing their national standards with the IEC relevant standard. Again, very specifically, lightning and earthing protection was used using the IEC code
Okay, instead of IEC 62305, it is now SASO IEC 62305. For all the parts, there are 4 parts of the standard, and all of them has been adopted officially by SASO. This drives us to a very important conclusion, that there is a big advantage in Saudi to use a SASO standard officially. Why? Because technically we are working on the same ground as everybody else. So IEC is no better now. BS, actually, it is the same. So SASO is also the same. So it is good practice to encourage the consultants, the regulatory authorities, designers to use the SASO specification. The other thing is remove the confusion. We open one document and we see a BS, we open another document and we see a DEN. All this is not necessary, it creates more confusion, so what we do, we just adopt the SASO because it reflects the current highest standard followed in the world. The IEC standard has got different parts. First part is general principles to the lightning protection. The other part is lightning risk, and also a protection measurement. A protection measurement has 2 elements. The protection measurement inside the buildings, outside the buildings. I mean the damage, the risk that can happen to the building itself, whether it is a power plant, a substation, or any other building, and the IEC 62305-4, it is for mainly surge protection measurement, which takes care of any surge protection inside the building. Okay? So the first one is for the physical structure, the other one is what happens inside the building. I'll put a little bit more emphasis on the risk assessment, because in the new standard, there is a lot of emphasis on the risk assessment. Risk assessment is basically divided into 4 levels. Loss of a human life, and as the colleagues mentioned, this cannot be valued. We cannot put a number on the loss of a human life. So this is the first one. Second one is loss of service to the public, whether it is a refinery, a substation, a power plant, loss of cultural heritage like a school, a museum, and loss of economic values. It is basically the equipment itself. What have we lost in equipment and the consequences of losing this equipment. When we do the risk assessment, there are 2 criteria. There are an objective criteria and there are a subjective criteria. Objective criteria handles the physical aspects of the body, of the structure we would like to protect, whether it is a power cable or it is a building. A building could be anything. A substation, a power plant, generation, anything to do with that. And subjective is basically to do with the use of this building. Okay, I will just draw one example. If we have 2 tanks, one is filled with water, the other one is filled with gas. The 2 tanks are very, very identical in the height, in the material, in the structure, and everything. Of course, with the subjective risk assessment, the tank that has got a gas would take a higher risk assessment level. In order to do the risk assessment, the standard specifies 150 parameters with 50 equations. All this has to be worked on in order to reach to the right assessment level. Whether it's level 1, 2, 3, 4, it depends on the priority, how the risk is there. Okay? There are so many factors in the standard. Now, luckily, there are commercially available softwares that you can put all these parameters and would evaluate the risk, will define the risk from there you can build your own, it will give you a recommendation on how you will build your lightning and earthing protection system. Three simple elements make any lightning and earthing protection system is the air terminal system, how to capture the lightning strike, the down conductor, how to safely direct this lightning strike to the earthing system, and then how to disperse this lightning strike or that energy into the earth. This is also an important part of the development on the standard. Initially, standard was talking about material. What material you can use or what material you cannot use in the making, in the component of the system. This has been abolished for very good reason. Sometimes people use good material, but they still corrode. And as we know, in any earthing system, you have three elements. You have the down conductor, you have the earthing rod, and you have the clamp. If the clamp corrodes like this, you will lose the connectivity. If you lose the connectivity, your earthing system basically doesn't exist. So the standard now does not call for material, okay, as we can see here in the previous version. Now it calls for testing requirement. It has gone one step ahead, and now we need to do the testing. What is the testing? What is the pass criteria for these components? Okay, and this is very important developments. In the testing, basically you have a selection of the configuration on the right-hand side, as we can see, of the connection, which is basically the connection arrangement, selection of the clamp, okay, and the selection of the tightening torque on the clamp. Because all this has to be verified after the testing. We subject all the material. We have to provide 3 specimens. We have to subject all the specimen, the 3, into an aging process, okay, which people are involved in testing, they know very well. And then we pass, simulate an electrical, a lightning strike of 100 kiloamp, and then we see what happens to the specimen. Okay, you could see here a little bit of deformation because of electromagnetic forces, and then we test the unscrewing, the torquing of the screws. Is it still within the acceptable limit? Because some screws basically they dismantle.
مهندس محمد.
تفضل.
الوقت قليل.
خلاص. This is just a simple example on a good clamp and a bad clamp. You could see on the left-hand side with the test, basically the clamp would snap. The standard does not leave the report to the manufacturer or the testing lab. Now, the standard specifically picks up what needs to be in the report. And all these needs to be mentioned in the report to have a professionally, standard-wise, accepted testing of this material. Thank you very much.
شكرا مهندس محمد على العرض القيم.